Basically, the big question with this stuff now is I'm going to give you a set of data, and you guys are going to come up with an equation for the data. You're going to look at the data to decide what type of model it goes through. And what I mean by that is, can you tell by looking at the data if it's linear-ish, quadratic-ish, cubic-ish, or quartic-ish? Fourth degree. Okay. Now, fifth degree. They run out of fancy names.
It's like N9.
I don't know. It's like once, don't say, trace, contorce, and then all of a sudden he has a 6 hash, you know, and it starts all really cool until you get to 16.
16.
So
Sound the same.
what we're going to look at now is how this stuff works. And how this is going to work is all based off of the calculator. So what I need to do is show you how in the world to use said calculator, which means I have a big giant handout.
It is big. And not
Yes, ma'am. Yes, ma'am.
Do we have to return this? It's up in. It's pretty fast.
Mr. Fontana made this last year when we first started introducing some of these regression modeling. They do a lot of this model stuff in regular algebra.
That wasn't me. It gets worse.
Why are you writing stuff on her agenda?
What?
You're talking about angle side side on her agenda.
Doesn't care, just keeps going.
It's recording. Oh. That'd be funny to hear when she says it. All right. So in this sheet here is this giant handout of what in the world is going on. Okay. Now, what I need you guys to do is we're going to kind of walk through what a regression thing looks like and what your calculator is able to do with the example on this sheet. So here's what we're going to do. We're going to follow it verbatim, which means word for word. I'm expanding my vernacular. Potato, potato. So according to this, it says the first thing to do is
Press second memory.
second memory, which is the plus key, and then number 4. Number 4 is going to clear out all of your lists, and you hit enter.
What's list?
You'll get there.
Why does it clear all lists?
Because your calculator is able to store data lists, okay, for doing this type of model. I have one.
No, one of those.
It's the same thing.
That one looks cooler.
She needs a puzzle.
That's the second time today she showed me this.
All right, so now you've done that, right? Everybody says clear list.
Yeah.
Okay, so we go to step number 2. It says enter your data into lists L1 and L2. Well, how do you do that? Well, you hit second, quit, to return to the main screen, which we are. Press the button that says stat.
Stat.
Sorry, not seeing that.
4.
Stat is the button underneath delete.
Oh.
Okay? Press stat, and you want to hit press number 1 to edit.
Wow.
And then you come up with this screen. Everybody have that screen?
Yeah.
Everybody not have that screen.
Are we going to use on the test? Or are we going to have to remember how to do it?
You'll remember it, because it's actually, when you do this a couple of times, by the third time you do it, it's the same process. It's very, very easy to remember. Okay? So what I want to do here is, notice how they have on the sheet here the list of 71, 61, so on, for L1 and L2. Let's enter in those values. And all you have to do is, well, let's see, it starts with 71, hit enter, 61, enter, 66, enter, 72, enter, 73, enter.
Those are like those.
Okay?
It's a little bit worse.
So now to get to the other column, just hit to the right and enter in L2. 191.
Whoa.
Something didn't go right.
Then we should have that. Does everybody have that? Did you get okay, Dad?
Yeah, I'm good.
So now, we need to, before we graph these points and all that kind of stuff, we need to set up a few things. So, hit second, y equals. That's the stat plot, it's called. You'll notice that it's in like superscript, it's in that blue lettering. Everybody see that? So you hit second y equals and your screen should look like that. You okay?
It's supposed to be blue?
Oh no, the letter. The blue lettering. Now, what you want to do is you want to make sure you turn on the stat plotting. Right now, you'll notice it says plot is off. Everybody okay with it? See how it does that? To do this, just hit enter,
Whoa.
and it changes into a new screen. See how it's blinking on the on now? If you're still at that main menu, if you hit enter, you get to this. Now what you do is just select it by hitting enter.
Oh, wow, that's cool.
That is
So it's now
big.
set up like that. Now the other ones should already be preset. You'll notice that you're going to want to create, if you look at this, it's a little bit easier, it's kind of like a scatter plot. It's just going to plot the points. It's not going to connect the lines. You could connect the lines if you want. You can do a bar chart if you want. Box whisker plots, box whisker with other stuff. So it can do all that kind of stuff for you. So now you have that, but think about the data that's in your table. If you think about what the data is in your table, if you went to your window, or excuse me, if you hit graph right now, you probably won't see it. Oh wait, clear that out, sorry.
Because you put
I got the most important
less
stuff.
clear. I don't get that.
See, right now your lists aren't going to show up in there because think about the data points you put in.
Wait, what did you?
Nothing. I just hit graph just to show that you can't see it. Okay? So what you want to do is look at where your data lists are set. And you want to adjust the window to see them. Okay? Well, it's cool. If it worked, it's great. So what I'm going to do is hit the window button. And I'm going to adjust my window so that I can see my data. Now, if I'm looking at my list for L1, those are my x coordinates. My L2 are my y coordinates. My x coordinates have a minimum at 61 and a maximum at 73. Everybody see that? So what they're saying to do is set your x minimum at 60, your x maximum at 75. Now you'll be able to see all of it. You okay with that?
Yes.
You do the same thing with your y values. Oh, here's what this x scale stands for. Instead of going by ones, it's going by fives.
Oh.
That's what the scale means, okay? So if you want to change that to a 5 to mirror that out. So now it's going by fives. All right.
Wait, can I just leave that one?
What's that? You can leave it at 1. It should show up. But it's just going to truncate a little bit so you might be able to see it a little bit. That's all. Normally, you don't really have to mess with the scale a whole lot unless your data points are really out of whack. But you'll get there. Same idea with our y values. If you notice that your smallest y value is 108 and your largest is 195, so that's why they set it at 100 and 200. Okay. And I think they did their scale by 20s, so it all shows up. Okay. And now I'm going to hit my graph. And there's my data points. Everybody see that? Okay. Did anybody not get that on their screen? Oh, yeah. Oh, it's because your scale's a little bit busy. You have it at negative, so you can change it to positive. There you go. Guys,
What is the meaning of right-wing regression? There's just those little lines kind of.
it's thinking. It's just thinking. If it's that little line in the side here, it's like moving up and moving around a little bit. It's just thinking. That's all that means. It's working on it, getting there eventually, slowly but surely. All right. So what we're doing now is flipping it over, and we're at part 6. So this is where it gets to be pretty cool. This problem here, if you look at your data points, I'm just going to kind of pull this off here. If you look at your data points, it appears as though it's going somewhat linear. If you look at it, you'll be able to tell the difference between what this looks like versus a curve very, very quickly. Okay. You might have done some scatter plots. You know, it's been a long time since you've seen this. And we're not going to deal a lot with linear. We're going to a little bit more with the polynomial stuff. And it's a little bit easier to see. The process of how the calculator does it is the same. We're just using this one to set it up. So what I want to do here is show you that the calculator will come up with the equation for it. Okay? Here's what happens. If we go back to our calculator, and we're on step, what is this, 6, hit second, quit. Now I want to hit the button that says stat again. The second option on there is for calculate. Move over to that screen. Hit to the right. And now what we're thinking is that this might be a linear equation because it appears as though it's going into a straight line. So I'm just going to select number 4. And hit enter. Go. And it should come up with that. You might have to do a couple. Everybody's calculator might be a little bit different where it comes up. How many times do you have to hit enter? Now, 3? Okay. I know that when we get to the quadratic stuff, it's a little bit quicker. So when you hit enter a couple times, are you getting that data?
Yeah.
So here's what it's doing. It's working with this, with the set of ordered pairs here, and coming up with what they call the line of best fit. What's the equation of the line that best fits those data points? Hit calculate. Go down to number 4. Enter. Enter. There you go. Oh, you might have just hit the wrong button, that's all. Okay? So in this case here, notice what it's saying. You asked to find it in terms of a linear model as y equals, think of this as mx plus b, where this value of a is your slope. So it's telling you the equation of this data is y equals 6.18x minus 270.81. And that would be the equation of best fit for that. The calculator does it for you. Okay. Now it does the same thing then with quadratics and stuff, or cubics, or any of the polynomials. Because if you go back and you look at, if you look back at your stat button, if you go to calculate again, linear, quadratic, cubic, and quartic. What that is saying is that I can write a first degree polynomial, a second degree, a third degree, or a fourth degree. It's telling me that the calculator can do it for you. Now, the tricky part comes in when you have to identify which one to use. And this is why we do this after doing all this polynomial stuff. Because if you have a third degree polynomial, up to how many changes in direction do you have? 2. If you have a second degree polynomial, how many changes in directions do you have? If you have a first degree polynomial, do you have any changes in direction? No. Yes, ma'am.
The second degree polynomial just means that like the first number is squared.
Yes. It's an x squared term. It'll be an x squared polynomial. If it's a fourth degree polynomial, you would have up to 3 possible changes. Are you okay with that? So here's what happens then. You can take a set of data points like this and then decide what is the equation that fits it. Yeah?
Is the second one the y?
Yes. Yep. So here's what I want to do. I want to take a look, and this is kind of how this works for every single one of these. We're going to take this data set. This will be L1, this is L2, because X and Y. I want to walk through how this goes. Okay. Excuse me. So your list 1 for your x values are just 1 through 6. I'll let you guys write this up here, and I'll show you how we set this up. Our list values for x become 1 through 6. And then our y values, our f of x, are the following points. Now, in order to decide which model we're going to try to work with, whether it's going to be linear, quadratic, quartic, or cubic, one of those 4, what I always say to do is do a quick little rough sketch of what it looks like. Now, it doesn't mean marking off tally marks all over the place. It's just kind of placing dots in space to get an idea of where things are going. Okay. Do you agree that I can say that this table is going between first and fourth quadrants? Quadrant 1, quadrant 4? We okay with that? So what I'm going to do is this. I'm just going to look at it like that for right now. And if I know that x is 1, y is negative 1. X is 2, y is negative 4. X is 3, y is negative 3. 8, 35, 84. So it's kind of doing this, isn't it? Everybody okay with that? All right. So, excuse me. When I'm looking at that, we need to figure out the number of terms. Decreasing to increasing. And this is where it gets a little weird. There's 2 turns. It's going down, then turns up.
Wait, how are there 2 turns?
This is where, when you're looking at the graph thing here, this is where it gets a little bit weird. And you'll start to, you'll play into this a little bit here. Let me show you what happens. We enter this into our table. Remember, we're going to go backwards to the beginning again. Quit. You want to hit second, memory, forward, clear your lists right away.
Wait, do you have to do that, Thomas? Can't you just?
A lot of times, I mean, you can overwrite it, but sometimes if you overwrite it, you have more values than others. It's easier just to re-clear it. So what we're going to do is we're going to go back to the very first stop, the start here, and you're just going to re-enter your lists. Okay? So your new list then, we just hit stat, edit, and I'm going to go 1 through 6. I have 6 values. We cleared it out. Why?
We don't want to.
Yeah, we were just following an example. We're doing another one here. And now I just entered my second list. What was it? -1, -4. 8, 35, 84. Everybody got the list okay? Second. Oops. Go to stat again, calculate. Now, like I was saying here, when you're looking at some of how these graphs work, you're only given a specific amount of data. You don't know where the tails were coming from. Okay? You're not exactly sure. When I'm looking at this and I see just that one dip like that, that means there's something else going on. Okay? What I want you to think of is that when you see just that little U, I know you want to think, okay, it could be quadratic right away because it looks like a quadratic. But that means there could be something else happening. Add one to it. And it'll make more sense with the next example because the next example I have is a quadratic. You'll see the difference in the graphs. Choose this as a cubic in your calculator. Choose it as number 6. I have to hit mine a couple extra times. It's a little different operating system than what you guys have. And with any luck, you get that. Cubic. And I'm going to show you why I want you to choose cubic versus quadratic. Hit stat, calculate, and I want you to choose cubic for this one. Number 6. No, you should get to the equation first. Oh, you hit stat, that's fine. There it is. Here's the wrong one. Now hit enter. It should work. So, what's happening here, are you guys getting this? Yeah. First term is 1, -4, C is 2, D is 0. So that means that the equation would be x cubed minus 4x squared plus 2x. That's what's telling you that that equation is. All right. Now, the difference between this versus a quadratic one is you notice how it started out with at 1 and then it dipped down and went up?
Yeah.
Well, when you have the other one, make sure I get the right data set here. When I do a different one, for my x, I'm going to use that xy thing. I'm going to use 1 through 6 again for the x. This is a different example. I'm going to show you how the difference in the data points when you rough sketch it, why does it look different versus a cubic versus quadratic. And I want to show you why it looks different from a cubic to a quadratic with data points. Because that's usually the weirdest thing that you guys have trouble comprehending. So my data points here wind up being -4, 0, 10, 26, 48, 76. When I rough sketch that, does everybody agree that it's still Q1, Q4? First and fourth quadrant? Okay. When I rough sketch that, I'm starting it here, and I'm just going up, right? So it almost looks like it's linear-ish, but it's increasing too fast to become linear. Notice how there is no change in direction in this curve that you can see. It's just going up one way. That means that it's a second-degree polynomial. Whereas the other one, see how it changed direction and then went up?
Yeah.
That means, see, that's the difference there. That is showing that there's two changes here versus one change. That's all it's showing up. Does that make sense?
So pretty much when it looks
What if
like
it's linear?
We're not doing any linear. We're not doing linear. Yes, ma'am.
pretty much when the line seems like it's going straight up and it's
Quadratic.
quad.
It can be cubic or quartic. So if it was a quartic, I'm sorry, go ahead.
Oh, like, does that also count if there were like one term and then it was going up, would you consider that 4?
Yes, because then you would know how it would look. You'll do ones later that have that fourth degree, so you'll see in the curve 3 changes on your rough sketch to know that it'll be fourth degree. Does that make sense why they're different?
Yeah.
No? Okay. Do you agree that this just looks like it's doing this?
Yeah.
Okay. On the other one, this one went down, then went up. The difference with your rough sketches is showing that there was an extra change here, whereas in this one, it's just going one way. So the rough idea for, I don't know, rule of thumb, think of it as an additional degree. There's just two, there's one going here, so it means it's a second degree polynomial. If you see 2 curve, it's a 3rd degree. If you see 3 curve, it's a 4th degree, and so on.
So the first one we did was cubic and this one was quadratic.
Yes. So when I go into my lists, was it second quit? Go to my stats, edit. I'm using that same L 1 through 6, so I don't have to really retype it if I don't want to. My other values were what? -4, 0, 10. Help.
26.
Thank you. 26, 48.
76.
Thank you. So I have those values. So when I go to calculate this, I go back to my stat, calculate, and I'm going to look at the quadratic, option number 5. And it's giving me my quadratic. Did everybody get that okay?
Yeah.
So you can see how, now Matt, you were saying earlier, well, you get to use this sheet, but you see how it's kind of the same thing each time? So it's really not that bad. Okay. Do a couple of them, it's going to be pretty easy. All right. So you would write it out, you know, it'd be 3x squared minus 5x minus 2, and that would have been your quadratic that fits those points, fits that data set. That's regression.
Yeah, that's not like
Want to try a few?
Yeah.
I'll give you a few. On page 384. Let's go to the board.
I'm excited.
Could we throw the homework on the back of our example?
That's fine. Not a big deal.
Oh, this is it.
Let's do.
Well, there's wait, so what are we supposed to do?
Write out the equation.
Okay.
Write the equation.
Okay.
You're going to be given data. What's that? Yeah. You're given the data, and then you just have to decide: is it quadratic or cubic? I forgot which one I didn't say. You got to figure out that. So that's why I say try to rough plot it real quick. Just do a little rough sketch, and then go through the motions of putting it in the calculator to figure it out.
These always on the board.
Can we just like do it in our calculator, like graphing?
If you want, but it's a little bit quicker. That way you know which one to choose right away. All right. What's up?
I wanted to really go and go to bed.
No. Because you don't know what it is. This is allowing you to find that.
Yeah, I know. Like the process.
You put the problems on there?
Yeah, I'll put them up there.
So I'm just doing it today.
And so did we have the same exact score. And we always.
Like I said, I'd recommend throwing it, doing a quick little rough sketch. Just get the idea of what it's going to look like, and then just that way you know whether this be a square, third, or fourth degree polynomial. Okay.